Hello. It is a good morning because we have progress on this frickin' bug. How did the obj dump stuff go? It was long and painful, but we have. I'll sum up again once people show up. But you see this here? Okay, we have something very, very, very weird. But this was the relocation that we dumped in the executable last night that is clearly wrong. And this is the address where we're crashing. The weird fucked up thing is this is the machine code that is supposed to be in that address. I'm actually starting to think I know how that could happen, maybe. We'll talk about that theory in a minute. But then I was like, oh, maybe the executable remapped this or did something weird. But like, this is from the object file, and it's exactly the same. So we are writing an object file with the wrong data in it, which means we probably are corrupting our memory. This is a huge improvement. We have not solved the problem yet, but it's a huge improvement. I'm going to start up some tea water. And we're going to have some caffeine. And start looking at things. Right. How's it going, everyone, this morning? Okay, we actually don't need this anymore. We have this. It looks exactly the same, but that's fine. This came out of our obj file. I'm not sure. I'm not sure what these actually are. Isn't it really sus also that this is the same for all of these, and then this one it's not? That's pretty sus. That is pretty sus. Wait, did I wrap the file? I guess so. So are these... Here's what I don't get. Here's 1, 2, 3, 4. Fifth byte. So 4 bytes is more than 2 gigabytes. So this isn't a local offset into anything. What are these huge address relocations that we're writing out? I guess they're already mapped to some, like, I kind of just want to see the source data, right? It loads at 40000000. That's still pretty far. You sure it doesn't load at 1400000000? Anyway. Oh, you know what? If this is adding, we could actually figure out what is being added here probably. Because we know that this is the code from the frickin' thing, right? And we can subtract out. All right, I have a theory. I will say what my theory is before I turn on the tea water. There's this really dumb thing in relocations where on some operating systems, you put the offset in the target memory. For example, in Windows by default. When you make a relocation, you say, okay, here's where in the code it is, right? And you put the offset in that place. And in other kinds of relocations, such as like 64-bit ELF or whatever, I don't remember, you put the offset in the relocation record. And why is it one way versus the other? Well, the old way saves memory or whatever, right? Now, we might be, in order to run consistently on both APIs, like, we might be putting the offset into the memory and then pulling it out for relocations that need us to list the offset separately. Which explains how, if the target address got corrupted, we could pull code out of the code block. You know what I'm saying? Like that could actually happen if it's something like that. Can this be a relocation that results in an external string from another module? I don't know, but that doesn't matter. That doesn't matter because this is... So what we were looking at yesterday was the relocations from the object or from the executable. But just this morning before I started the stream, I redumped them from the object file. And this is the same. So this is not being modified by the linker. So we are writing this out in our file before the operating system or anyone touches it. Well, okay. I don't know where these numbers that that dump bin is outputting are coming from. You know, if we can cross-reference I don't know. Anyway, if we can get one of these other tools to dump relocations, we could maybe see the source data of this one. But this seems like enough information to kind of tell me what's going on. You know what I'm saying? Okay, let me set up drinks and stuff. Okay. Why did the linker complain sometimes and sometimes not? Well, if we're corrupting memory, then maybe sometimes when we corrupt memory, we don't actually corrupt our relocation, right? Or it could be other things. Maybe we're not corrupting memory. Maybe, for example, sometimes we're adding a relocation at the end of a loop, but we don't fill it in. Like you could imagine we add a relocation to the array, but then we don't actually, because then we break from the loop or something, and then you don't fill out the members of that struct, and so it gets whatever memory was there. But this is kind of the smoking gun right here. So we could at least maybe add some assertions. Like, look. If we ever output a relocation that's this big, clearly bad, right? Now, normally I would say I don't quite know where to assert that because it could be corrupted before we write it, or it could be corrupted after we write it, right? But the fact that it contains code that is correct in a place where that code should not be leads me to believe that it happens before we write it out. Or, okay, here's another theory. Because we have these buffers that we throw around and chain together, and maybe there's like a bug in the buffer where we go past, like this was supposed to be the end of the page, and we just go a little bit further. And then it would happen after wherever I would put this assert. See, this is why this is difficult. Yeah, this is dump bin slash, I'll show you the command. This is dump bin slash relocations on the executable that is causing the crash. And this is our bad relocation. Have I looked at the definition of dir64? I have not. I think the right-hand side is just what is in the exe. dir64 just adds the difference between the base and the ASLR base address. I mean, I kind of don't believe that because these numbers, I think, are way too big for us to have written out. But I'm not sure. I mean, is there anything that we call dir64? No. Oh, this is probably in... Okay. Okay, so the main thing that would patch the text section, there's a few different places where we add relocations for the text section. So this is a 32-bit patch. This is a 64-bit. And I think this has been edited since last time I worked on it. Okay. So is this in... So we could be... So this is where we write the relocation into the actual thing, right? We could be here stomping the fucking thing, right? So if we're on Linux, you don't put the offset in the code. If you're on Windows, you do. So if this is wrong, if this is somehow pointing to the wrong part of the code, then we'll overwrite it. But the weird mystery is that they're both wrong. Okay, but I believe we could put an assertion here, or yeah, we could put an assertion like up here where we say the high bits of this had better not fucking be set, right? Wow, dude. Look at this comment. Does Visual Studio parse the comment out and put it? Wow. Okay. That's cool. That's the first useful thing that I've seen it do in a while. So I think my next step is to put an assertion in here and then run it a bunch of times and see if we hit that assertion. Dir64 used for something like void pointer something, void I reference something statically equals ampersand something. Yeah. Okay. So we're just going to put a really stupid assert in here and see if it helps us. So because in this one case, so now how many is it? 8 more. Right? Is that the right number of zeros? So we're literally just going to do this and see if we can catch something. Let me just make a new folder here, or a new thing. So we want to run debug compiler. And this is going to take longer every time. But we're just going to wait it out. We could, it's been on my list forever to remove some asserts from the debug compiler so it goes faster, but I just haven't. So that didn't hit that. I should run it every time, just so we know. We're just going to do this for a little bit, folks. Okay. Let's run it back. It took quite a few runs last night. In fact, I don't know. We were speculating that we might want to have other load on the machine. To help it happen. So I'm just going to start those. Maybe I should keep the game running. If you can't make something useful with 32-bit per process, you probably won't. What? No, that is completely false and nonsense. Just don't make stuff up like that. Firstly, there are entire games now that... Okay, so this happened because one of our build servers was rebuilding. Lol. Wait, unknown host name. Why are we getting unknown host name? Dude, computers are so broken, I have no idea. All right. Okay, that I didn't mean to do that. So then also, what is happening? Oh, this is still compiling. All right. Let's just kill this for now. Oh, you know what? Let me just run it every time because, like we said, the debug info patch thing is visible, but yeah, we might be in for a very long road of just doing this over and over uninterestingly. When will 128-bit become a thing? Probably not for a while. Like 2 to the 64. What is happening? Did we leave a debugger process? Like, why is this happening sometimes? Yeah, I wouldn't say it'll never be meaningful, but it'll take a while. Like, I forget what the number of particles in the universe is, but it's like maybe 10 to the 53, which is less than 2 to the 64. That said, as I was going to say, if I didn't say it in 64-bit, there's lots of like virtual memory things you can do where you allocate different chunks of address space to things, and then you don't use most of that address space, but you might, right? And that's what gives you the power. Well, you know, that kind of thing someday maybe could use 64-bit. (10 to the 80), is that true? Let's look this up, because 10 to the 53 and 10 to the 80 are very different. Number of particles in the known universe, in the observable universe. Oh, it's 10 to the 80. Oh my God, I was so far off. Okay, so I was wrong. We're going to need 128 bits. You have a multi-precision lib that would very much like 128-bit registers with 256-bit mul. I mean, sure, but like, it's not that bad. Okay. Saying that there's 128-bit registers or 64-bit registers isn't really the operative thing. It's like, how fast can the machine do multiplications, right? Like, can it actually multiply that many bits at once or not is what matters. Because it's not, you know, if there's a 128-bit register, but when you issue a 128-bit mul, it takes like 253 cycles. That's not going to matter, right? So now most of these machines have an ALU that'll do at least 2 integer multiplications at the same time, right? And so when you do your like big num multiplication, it's cross terms that don't depend on each other anyway. So like you're probably doing those in parallel anyway. So I'm not sure that you necessarily gain much by 120. I mean, if you have 128-bit registers, the code gets a little bit smaller because you don't have to do all the multiplies and carries and adds, but it's like, what we're really talking about is how many ALUs does the CPU have that will do this operation, and can you use them at once? How much even a 64-bit integer multiply, that doesn't have a latency of 1, right? That's got a latency of like 3 or something. What is a recent, I don't remember any CPU names past Coffee Lake. So I'm looking up Coffee Lake integer multiply latency, except I typoed the word multiply. Double precision divide. We don't care about divides. We care about multiply. Logic. Oh, okay, hold on. IMUL, AMD K7. Which column is which? Latency, throughput. 3, 2. On AMD K7, I don't know. We could probably find Wolfdale. I don't know what a Wolfdale is. Broadwell, Skylake. Skylake X, Coffee Lake. Okay, Coffee Lake. That's even from years ago at this point. IMUL 1, 2. Really? 64-bit. Dude, that's pretty good. Well, okay. I don't know which one this mul is versus this one. R64, M64i. So this is by a constant. And this is by a variable. I don't know. 2, 3 is still good numbers. So 64-bit CPUs can do your multiply pretty good. Okay. Let's go back to actually. So why am I failing to add to the manifest now? What is even going on? That could be like Windows Defender defending me from myself. Dude, oh. Shit. Okay, we got a crash, but our assertion did not fire. But this is good because we can observe another case in the wild. It's like Girls Gone Wild, but this is Bugs Gone Wild. Illegal. We frickin' jumped to a data structure. Oh no, we're initializing. It's the initializer for a data structure. This is interesting because that's also, or no, it's not the initial. It's, oh, it is the initializer, I guess. Okay. Let's just see what we got here. Okay, we're not in the pre-post amble of anything. We're filling out a triangle mesh. You can see that the code is still quite, we keep zeroing ECX. It's like it's already 0, but we zero it again. Why not? That would be better if it weren't for something someone did, but I don't know. There's always trade-offs. Okay. This kind of looks fine. This kind of looks fine. And then here, again, I don't know. I'm confused. Hold on. Let's rewind the spaceship back a while. In our other crash example, we only had 4 bytes of corrupt code, but we're saying this isn't. We're saying this is an 8-byte. We're saying this is an 8-byte relocation. Maybe it's not. No, but it has to be to have all this garbage in it. The Edison's in A2B again. No, this is the old one. I'm going back and looking at the old one. It did end in A2D. I don't know, did it? Oh, it did. That's a little weird. Isn't it? Like, what are the odds of that? What are the odds of that? Is the bug reproducible? No. What are the odds of that? That is really weird. Okay. So I want to do the same dump bin. Okay, before we do anything, we're going to copy this away. Let's just close this up for a second. We're going to go to our dot build. We're going to copy that. Oh no, that's the wrong one. I'm going to go to here. I'm going to go dot build corrupted exe2. We're going to go here. We're going to copy these baggers back to here too. Oh man. Okay, this is going to be confusing because we copied this executable in there like yesterday, so I don't want to make that mistake. Hold on, wait, what did I just delete? I thought I deleted the shortcut. Let me just paste these on top. Replace. Okay. So we have two examples of corrupted executables. Let me go back in here. I'm just going to delete these. Just so we don't confuse ourselves in the future. In the future's future. All right. The fun is that this can be a bug in Windows still. I don't think it can. I think it's very clearly our bug in the compiler. Now, the question is, what do I do next? Let's do this. Relocations 2. And what did we say? We said A to B. Look at that shit right there. What the actual fuck? It's at the same RVA. It's also got a 2. Like, the code's different, but that's because we're stomping it down in the different place. Okay, this is very good progress. This time it's like literally the only one. In that RVA, but it's right. It was 1F A. Wait, it's literally the same? Somebody explain that to me. You think you have an understanding of what is broken now? Well, okay. Maybe what you might not have been on here when I talked about this, but there is this weird thing with relocations, okay, where, you know, on some, so on Windows, when you do a relocation, you're supposed to put the offset in the target memory, right? And on Linux, you're like not. And so we have some weird code that we were looking at before. So like we add a relocation here, right? This is our internal representation for this. And we both get a pointer to the target memory where it lives. And well, this is, I guess this is like what the RVA is over here, maybe. Okay, hold on. I've got too many. Okay. So like here's where we tried to put our assert, but you know, there's this thing where you actually shove in the target memory this thing. And I was like, okay, this could be overriding our code. If the RVA or the offset or whatever is incorrect, but this didn't catch the problem here, and we also wrote something starting with 2, so I don't know. Yeah, anyway, you could tell me what you think is going wrong if you want. Is the compiler deterministic? No. Threaded programs in general are not deterministic, unless you force them into a deterministic mode, which we have the ability to do, but I'm not sure if this, well, there's determinism and then there's determinism, right? And I'm not sure if this bug can exhibit deterministically, even when we're running in deterministic mode. It's like, that's a whole thing that I haven't gotten into yet. Is that the air conditioning? Yeah, I'm in Florida in this apartment building where the air conditioning is very heavy duty. Can you compile the source without threading? Actually, you can't compile it with 0 threading because structurally it's not possible for the compiler to run without threading. At least I never figured out a way to. You can turn off the compiler's own threads, but the problem is there's user level code that has to sort of run at the same time. It's, you know, maybe someday I could go back and try to think about a way to square that circle, but right now it is not. In a good exe, does it relocate at 1FA2B? That's an interesting question. It's weird because I wouldn't expect these to come out the same every time. The relocation table is 2-byte entries, and if you look at those addresses, they're not aligned on 2 bytes, they're off by 1. So when it computes the number of relocations from the size in the linker, it ends up calculating one too many, and that tramples into the code section. Okay. Right, B is an odd number, right? B, D, and F are odd. So wait, is this the RVA inside the relocation section? So I'm not sure that I buy this theory because some of these are even and some of them are odd. Unless you're saying we screw up multiple times and keep toggling. And it's whether we end even or odd. But if that's true, I would expect a lot more of this problem than in one place. Like here's a 9. Here's a 5. And there aren't extra ones after that. Thought that RVA was where the... I don't remember what RVA means, guys. Like, I only look at this stuff once every 2 years at most, right? Yeah, I know what the acronym stands for. I just don't know what that means. It's the difference. Guys. It's a difference. You've got to understand, I do the entire compiler and also a game engine and also another. There's like so many things in my head. Like I just don't remember shit like what things are called. Why are people telling me what RVA stands for? I know that. That's not the issue. It's not the issue, guys. It's like, I don't know if that's the destination. I don't know if that's the target address within this section where the value is shoved. Or maybe this is just a table of contents and it's telling me where in the... But I don't think that's true, because if it were, these would be evenly spaced, right? And they're not. Are they? No, they're not. Wait. No, they're not. And we just force alignment in the compiler when generating the entries. In theory, we probably do that. Okay, hold on. Let's. Okay. Here's a relocation. Are these the actual relocations that we're talking about? Okay, these are 10 bytes each. Right? But if this is the address in the executable, there's no reason it can't be odd. So I don't know what you mean. Or, okay, so you're not saying the B is odd matters. You're just saying wherever this happens to end up, we like maybe write an extra byte or something. or the offset is like wrong. Is that what's happening? I don't even quite understand. This is not broken into sections here. Like, why is this not broken into sections? So here, these are every 8 bytes. So this is probably like the type table or something. 1B10000. I don't know. Each block must start on a 32-bit boundary. I don't understand where these blocks come from because we don't write these blocks. Like, I'm creeped out by what I'm looking at because I don't understand where it comes from. Also, what is up with these block sizes? They don't seem to totally correspond to how many entries are in them. Like, here's a size C block with 1, but then a 0 anti-lock braking systems. Same here, but here's a size C block with 2. Why do we have 0 anti-lock braking systems sometimes, but not other times? Yeah, I'm confused because I don't think we write these blocks out. So I don't fucking understand where they come from. Like, okay, we have on our side, we have, you know, a little higher level of representation where we know what we're supposed to be doing the address to, right? And here we say, all right, here's the symbol index of the target, right? Here's the addend, and based on the data type, we figure those things out. And then down at the bottom, Okay, we do this thing, which is sus. Which, by the way, I guess I should put that assert down here. I should put that in this loop because I'm actually not sure. You know, we always have a little bit too much in the way of relocation generation. I don't know why we have so much, but we do. I actually greatly reduced it, and there's still too much. But so let's just put some assertions in here, right? Because we... I don't think this is going to be it, but... Whoop. I did that last one wrong. I have delivered value. Okay. Like there's this +1 thing. Like, is it coincidence that we have exactly one bad relocation and then we're supposed to put an extra one for the stupid cough thing overflow? I don't know. I don't know, guys. The obj entries are off by a byte. But what, okay, if that's your theory of what's... Okay, if what you're saying is correct, none of these assertions should do anything that I added, firstly. Which, the other one that I added already didn't do anything. Okay. What is happening with it? I think this is like Windows Defender hosing me or something. How do you... What? I want not the firewall. I want the other thing. What? How do you change the thing that says don't fuck up my executables every time I load everything again? Under new settings app. Settings app. Attention. Look at all the attention that's needed. Windows secure virus and threat protection. Off. Oh my God. Guys, I need to make an operating system. But first I need to fix this bug. Okay. So if you're saying it's a byte off, how can we verify that it's a byte off? Is there actually information? Here's what I don't understand from the theory. Is there information in the file? What was even the file called? Soko debug relocations 2. Is there information in this file that tells us we're a byte off? That's what I don't get. Because we certainly have odd numbers. But this is like the target address, right? So like, why would that? I can add I don't want to add exclusions. I want to turn it off and delete it from my system. Like, the thing you guys, like, once they have you changing all their settings every week on every program that you ever use, you will never get your time back in your life. Yeah, I've read the PE file format document all the time, right? Each base relocation block. See, wait, this is image only. Doesn't that mean PE only? I am confused because we don't write out these blocks. Guys, what we write out is for each section, we say, here there's this many relocations, here's what they are. So I don't even know what these blocks are. The linker is, but wait, does the linker modify your object file? Because, oh my God, guys, I generated it from the executable. What am I doing? I thought this came from the object file the whole time. Hold on. Wait. Okay, guys, at the very beginning of the stream, I thought I pasted the command and changed it to obj and got output and said, oh, it worked. And I've been operating on that assumption for an hour. Okay. So how do we map this to here? Can I go 208C8 948? No. How do I map this back? 1FA2B. Okay. Okay, this looks so incredibly sus in so many ways. Like, look, it's the wrong type. This is a section full of debug, like, oh no. This is just us outputting trash at the start of the thing. Okay, this answers multiple questions though. Like, why are our assertions not going off? Well, maybe it's because I didn't put enough zeros at the beginning. Or no, I put 4 Fs, didn't I? But I put those after we generated this in those other places. So those might still go off. Let me check. Are we in the 4F club? You are not in the chess club. All right. So this is literally the first thing that we write out. In the relocations. Okay, now I'm lost already. It's like a big file, so scrolling is weird. Okay. Relocations number B. Is B the section number? Do we even go up to 1FA2B? Probably we do, because we had valid code at that point, right? Guys, look how many fucking relocations there are in executables. It's a disaster. Okay. So how does this turn into code bytes? That must be the linker doing the code bytes. Right? Because this doesn't have the garbage code bytes in it. So the linker is like pulling that value out of the code and putting it in the table and munging the code. What are our, do we know what our sections are? Are these in order? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. X data? If this is X data, that would make sense because that's a debug section. 1, 2, 3, 4, 6, 9, B. So no relocations in BSS, that makes sense. 1, 2, 3, 4, 5, 6, 9. I would expect some relocations in A. See, I just don't even know if these are in the same order. 6, 9, B. 6 is dot no reset. It's empty. So these can't be in the same order. Like, how hard is this? Like, make it clear what section these are. Unless it's one index. But it's not, because you're not going to have relocations into BSS. But, okay, you'll note these are in alphabetical order, and we probably don't fucking write them in alphabetical order. So, again, like, this output is trash in a way that it shouldn't be. So can I just do headers on this and see? I mean, we can look in the code to see what order we write them in. Okay. B is debug $S. So let's see if these correspond. So it's 1, 2, 3, 6, 9, B. So, okay, this is 1 based. R data, okay. Types, okay. Data, okay. No reset, empty. 6.text, totally makes sense. 9, P data is one of the debug sections. And B, debug $F. This is sus. Are we just doing this wrong? The FFFF thing, we could just be doing that wrong. That could be the whole goddamn problem. All right, you know what I want to do? Since this is the very first relocation in B, because we output these in the same order every time, I want to dump one that doesn't happen to be crashing and look at the first relocation. Is the first relocation garbage literally every time? And it just doesn't happen to kill us most of the time. Let's find out. Yeah, so the deal is there's only FFFF relocations per section in the old COF format, all right? In extended COF or whatever, if you have more than that, then you have to write FFFF into some field somewhere. Oh man, this one crashes. We got another one. Let's archive that. I wanted it not to crash. We could look at this in a minute, but actually, I want to look at one that's fine. Okay, but this gives us more information anyway because my asserts did not go off. Let's make sure we were up to date. We were. My asserts did not go off, but we still died. So that is information that those assertions ain't doing anything. So it is like some kind of, are you kidding me, dude? Really? Like we just couldn't get this to happen to save my life before. Maybe it's because we turned off Windows Defender and it changed the timing. Now we're running further. Okay, so this appears to run like many of the earlier things where we appear to run. So now, if I do my dump bin to OK.text, from .build, let's check this. So we're dump in relocations .build socodebug.obj. to OK. Let's check the time on this. It really is 9:27 a.m. It just got made. Dude. Okay. So let's go to OK.text. Relocations number B. Yeah, it's wrong. It just doesn't happen to stomp code fatally. How good is that? I think it's time to reward ourselves for progress. Back in a second. Now, by the way, guys, I would like to point out 3 hours of hard debugging later, all we have managed to do is rediscover what the linker could have fucking told us in the first place, which is, remember sometimes we got this linker error, debug information is invalid? If it had said relocation at index 0 of section B is invalid, would have fucking saved 3 hours. One fucking printf that somebody could have done decades ago. And if it would have saved 3 hours for me, how many people would it have saved how many hours on? Okay. More than 3 hours, 3.5 hours. Okay. Casey got me this cool gift box of Japanese snacks, or he got me a subscription to this thing, and then it ran out, and then I re-upped my subscription for my own. So now we have all these things from Japan. We have some kind of crackers that I don't know. We have handmade yuzu sake candy. We have like white strawberry. We're going to have one of these. We have, I don't know, some kind of thing. Like, there's so many things in here. Oh, we have happy face mochis. We need happy face mochis. All right, let's start there. There's so many things in here. We have taiko drummer, some kind of situation. Oh, look at this. We have death scary peppers. And there's different stuff in the box every month, which is great. So we have taiko drummers, happy face mochis, and whatever's in here. And I'm going to have a happy face mochi because I'm happy. You're right. I should have put it on Big Cam, but it's too late. You can look them up on the web. I will show you the website. I've shown it on stream before. It is these guys. It's like a subscription thing. It's a really great, if you want to get a gift for someone, you just get them like a 3-month subscription or something. I really appreciated it. They're super yummy. This is not an ad. I mean, it is an ad, but it's not an ad. And it contains allergen info. What more do you want? Okay. Super busy with relocation with Ukrainian parents and relatives. That is what I hear. I know a number of people either with Ukrainian relatives or who live in Ukraine or did live in Ukraine. And it's a busy time. This is a strawberry. Okay, people. So now we are writing the FFFF correctly. But we're probably, maybe we have to align after that, or like, who even knows? Here's the thing. Okay. So this is debug $S. And this has the flags. Maybe that 3, maybe the 1 in that 3 is the right flag, right? Read graphite masters wall of a con. That 1FA2B relocation does not belong. It's an extra one that should not exist. You're not writing this corrupted relocation. It's just reading past the relocation table I wrote. Then why does it think it's the first one and not the last one? If your theory is correct. Why does it think this is the first relocation in this table? So you're saying this ends on an odd byte somehow, and we're not padding? But the thing is, we don't store the relocations contiguously in the file either. We write out the section data, and then we write the relocations for the, I think. Maybe that's not true. Hold on. What we do, we have this thing called add segment raw data and write relocations. And let's see. We have a, okay, so we have a buffer for the segment data. That goes into the main buffer. And then we put the relocations into this relocations buffer. And then we steal it onto there. And here we pad, but only on Linux. So are we saying we need to frickin' pad on Windows? Is that literally the entirety of what we are saying? Table above, look at the offset. But that, again, the offset is the target address. That could be odd. I don't understand. Can't it? Or is this not, is this the... See, I don't know what offset this is. I don't know what that number means. Is that just where in the file we are? No, because we couldn't get such a wacky number. No, this is like the target. This could be odd. It's fine. I don't understand why you're saying it can't be. If that couldn't be odd, then there would be places in your section that you wouldn't be able to write a relocation into. We never proved that this is... No, this is definitely the bogus relocation. I'm pretty sure. We could double check to see if somehow, now that we know what section this is in, we can investigate what the code thinks it is doing, right? We can actually break here for this section and see what it thinks the first relocation is, right? That would be useful. Oh, these mochis are really good. 1FA2B should be in the table above. I don't think so. Because these are different sizes, and this doesn't go to 1F. I mean, 1A is kind of near 1F. I mean, if anything, this 1A3 is closer to these. It's being read as 1 and B because of misalignment. I mean, I understand that you're saying this. I don't necessarily believe that that's for sure correct. Dude, the Japan snacks. Okay, question number 1. Do relocations have to be aligned? And if so, to what? Because we are definitely not aligning them here. What if I just pad... What if I just pad to 128? Right? These Taiko drummer snacks are really good. They're like a savory version of Captain Crunch cereal. Nope, debug information corrupt. Although, I mean, maybe you can't just pad where I just padded. I don't know. Same. It's 1FA2B every time. Let's just see if for some reason we're actually writing that out. That 1FA2B should be the amount of relocations. Right. That makes sense because that's more than FFFF. And that also explains why. So maybe we're just not flagging it correctly. Let's do this. Let's break here. Where are we? 1111. Let's just see, like we probably have one FA2B relocations, right? Okay, we probably ran with the wrong options there. Yep, wrong program. Sukban. This totally makes sense now, guys. It's just we're not doing this correctly. And we never really tested it because most programs don't get big enough to trigger this, right? Okay. Info.number of drum roll, please, as we go into hex. Ding, ding, ding. Ding, ding, ding. We are not writing this out correctly. Now, I will point out, this is a complication caused by the old file format was not big enough. They modified the file format. They said, in rare cases where your thing gets big, just do this extra complicated thing. And now we're paying for that complication in the system. Okay. Let's go read from the official docs about this flag. See this flag? Yeah, and that has a 1. Remember how I said maybe the 1 in that 3 is the flag? That's what it is. All right, so I'm probably just doing... All right. Where was the PE documentation? Someone, this is literally what I get when I search for this. How about if we take off the underscore? There we go. OVFL. This section contains extended relocations. The count of relocations for the section exceeds the 16 bits that are reserved for it in the section header. If the number of relocations field in the section header is FFFF, which it is, we checked that, the actual relocation count is stored in the virtual address field of the first relocation. Okay. So then what's the problem? We're setting the flag. Who the hell designed this? This is what happens when your file format, when you're trying to tweak things and keep them backward compatible. Check if the flag is really set. It is. So let's triple, quadruple check. But when we did dump in / headers, right? I mean, that's a different file, but they're all the same. So section header B, flags 43. Okay, let's count zeros here, right? This has 6 zeros, right, and then a 1. So this has 1, I can't highlight, 1, 2, 3, 4, 5, 6 zeros, and then a 1. So we are setting the flag. It even says extended relocations, really? Oh, you must mean maybe in the documentation. Now, okay. Now, maybe this has to be a different relocation type or something, right? I don't frickin' know. Maybe we should make it sekrel or whatever. This piece of the documentation does not seem to care. Why are you linking me to reloc section image only? No, that's not, that's the wrong thing. Okay. There's a whole PE format document that we used to read all the time. OVFL indicates that the count of the relocation exceeds 16 bits. The actual is a 32-bit virtual address field of the first relocation. Okay, that's what we did. Okay, I do still have questions. Here are my questions. If we're writing this relocation out, what is this? Where's that data even coming from? Like what? Let's look at what is writing this out. Okay. So who sets overflow result? Because that's how we know to do this. Yeah, of course, note this comment that we're actually doing this fucking everywhere, which is a disaster. We better fix that today, by the way. We better fix that today. Okay. Anyhow, who, what? So we write a relocation here. Now, does this actual relocation count? I'm so confused about so many things. Okay, firstly, I take this to mean that the first relocation is not actually used, but it appears to be used. If it is used, how do you put something in the virtual address field? That's data, like what? Okay, ignore that. Should we put symbol index 0 here or something, right? Will that make it happy? Maybe it's trying to use it because the symbol index is not 0. And this is like some undocumented behavior. Maybe it cares what type it is, and the documentation doesn't say. There is no way it uses it if the overflow flag is set, but it is. It is using it. This is what is fucking up our code. It is using this as a relocation. Unquestionably, well, not unquestionably, but we're pretty sure that that is what is happening. This is where the trail has led us. Maybe its format should be 32 bytes, maybe. Okay, here's what's confusing me, guys. I'm writing in zeros for this stuff. So, like, what is going on there? Okay. Here's what we're going to do first of all. Let's make it, I don't know, 0 here. Image sim type null. Is that a thing? I don't know if I have that. Let's look it up. Type null. No type information or unknown base type. Microsoft tools use this setting. Yes, they are definitely tools. All right. So image sim type void and no valid type. So where does that go? What field does this go in? Okay, this is a section number. I mean, I almost want to find an executable or an object file that is big, generated by Visual Studio, and see what it puts for this relocation. WinCoff obj writer. Okay. Symbol table index 0, type 0. Okay, so if you don't do this, you're going to get kicked in the nuts, is what we're learning. So we're going to put 0. I don't know what type 0 frickin' means. Virtual address. What does type 0 mean? It does greater than or equal to 65536. Fake news. What are you with the fake news? Mine does greater. Okay. That's true. We could do this. This is not our problem because we have way more than this, but I could see that being an edge case. Okay, that's a good point. Image rel AMD 64 absolute. The relocation is ignored. Okay. I don't know if our thing will handle this. Right reload. Okay. No, we just write it in and it's the same size. Okay. Okay, guys. Moment of truth. Well, not quite. Absolute. Because it was Adder 64, it was being treated as an actual relocation. I suspect that is what that is the current suspicion. So now, first of all, we can do the dump again. Now, we didn't get an error, but we don't know because a lot of the time before we didn't get errors. Let's do OK3. Relocations. Anti-lock braking system. So, yeah, I suspect the linker doesn't give a shit about the flag. I suspect the documentation is kind of wrong or incomplete, right? And the linker doesn't give a shit about the flag. It just applies everything. And so you need to be anti-lock braking system. Five hours of debugging for this, guys. Five hours of my life. Although, to be fair, we did get to eat some snacks during that 5 hours, and that's pretty great. Do we even know that it doesn't crash anymore? No, but I'm pretty sure it doesn't crash anymore. I mean, okay, if we're going to get very, very technical, okay, let's go back to that text about overflow. The actual relocation count is stored in the 32-bit virtual address field of the first relocation. It doesn't say the first relocation is ignored, therefore. That is just something that a reasonable human being might infer from the fact that you're putting trash in that field. It doesn't say that. So technically, the documentation is not wrong. It is just written by assholes or people who didn't know that you should also say, semicolon, however, linkers will not ignore this field unless you make it a type that linkers should ignore. How long has this been an issue? It's been an issue the entire life of the compiler, probably, if we have correctly fixed the problem. The thing is, it only manifests for sections that have more than 64K relocations in them, which most programs don't. You need a PhD to write docs. I mean, Also, like if you, so on the one hand, it is good in the format that they check these things for consistency here, but they should have also said it's an error if the flag is set and the relocation type is not anti-lock braking system, right? Like something like that, even that, it would have been okay when you go to read the docs and implement the thing, you're like, okay, I better make it anti-lock braking system, right? But they didn't do that. And it's all just to say this stuff matters, guys. Again, you have been able to witness how much of my time this one thing wasted. Because, you know, I implemented this, I don't even know how long ago, years ago. And when I implemented it, I was like, okay, let's just put a first relocation there with the information. It seemed reasonable. How many people who write utilities that write object files have made the same mistake? And how many programs that made the mistake still have the bug because it didn't, like for us, it worked most of the time. It appeared to work most of the time, right? Because we didn't stomp our code most of the time. Would have found it hours ago if the linker just said what is wrong. That is also true. Yes, the linker knew exactly which relocation was wrong. It just didn't tell me because it doesn't care if my life is terrible. Okay, we're gonna have mystery plant cracker. How many Microsoft tools are broken in this subtle way? Maybe not that many of Microsoft tools because they don't really like to write new code that does anything. So they probably just call the old code. Casey will do a React.js stream when it gets 2,000 subs. I think I might have to gift some subs. So yeah, guys, this 5-hour debugging session probably would have been 15 minutes if the linker had just said what the problem is. And that's true for all of computers that we use today, by the way. Like everything is like this. Now, it probably would have been more than 5 hours if chat people were not prompting me on certain things. Now, that also put us down a couple wrong roads and diversions, but it was probably more of a time saver than a time loser. So it would have been more than 5 hours. And now imagine, so like, I mean, I've been programming for a long time. Imagine that I subtract 20 years of programming experience from myself. We're not trying to calibrate against anyone else, but like 20 years ago, I was less good at programming. So how long would it have taken me then? Like, it's just all this stuff, man. All this stuff. But we finally got it. We have finally succeeded. Don't forget the to-do. Yeah, it won't. Our check-in system will not let me check in until I fix that. Okay, let's first, let's make a release build and run it and compile it a few times. Oh, we made a release build. So we should be able to do this and run it and do it and run it and not have this problem anymore because we have engaged the anti-lock braking system. 20 years ago, would the linker have just told you the problem? No. No. This is a way that software has always been bad, especially system software. And there's really no excuse for it. Like, okay, in 1970, there was an excuse because you cared about every byte of your executable. Since about 1985, there has been no excuse for this kind of thing. Because it literally takes you 5 minutes to put that in as the developer. And I don't know, let's say 100 people have had this problem, right? 500 hours minimum, right? What is that? That's like, so 400 hours is 10 full-time work weeks, right? So it's 12 and a half full-time work weeks that you save with 5 minutes. Like, not even 5 minutes, right? Like, how long does it take to change your printf format string? It's like 1 minute. And everything in computers is like this. Okay. I mean, how many times do we run it before we're convinced that we don't have this problem? Imagine the collective human time. Yeah, I mean, I think for this one, it's not as big as for some other things because not that many people make programs that write out object files. But, you know, like we've been saying, this is a problem that happens in a lot of, it's a kind of problem that happens in a lot of domains. Why is our compiler so slow now? Like, why is this 1 second? That's kind of bumming me out. I don't know what's going on there. We have to go figure some stuff out, I think. You can only imagine how miserable life is for LLVM developers. Yeah, I would never work on LLVM because I want my life to be better than that. Like, I feel like this is working, right? Get rid of some of our stuff that I put in. So these things can go. That was never the problem. These can go. That was never the problem. This can go. Okay, so we need to do this, 1125. In obj writer. Okay, this file is modified for some reason. Oh, oh geez. It was modified because okay, let's do this again. I just didn't save it out after doing this. Repeat. Pete and repeat were sitting on a fence. Does anyone under the age of 49 know that one? Okay. That's how kids used to amuse themselves before the internet. It was by saying Pete and repeat were sitting on a fence. Okay. That's so stupid because repeat isn't a name that I have ever heard. Okay, so going back, 1125 here. In cough files, we need to do this special garbage when our number of relocations would overflow. Now, here's the thing. I am tempted. I think it's actually greater than 65535 is probably correct. However, I don't want to risk it. Thanks for pointing that out. LLVM does that. Wait, was that LLVM code that we looked at? What was it? What even was it? Oh, this is LLVM. Okay. Fuck them. Okay. So we need to say, all right. We found out the hard way that the first relocation, even though it must be junk in order to hold the number of relocations, is not ignored by the linker unless it would otherwise be ignored due to its type. This made me sad for 5+ hours of debugging. Okay. I'm going to really enjoy telling Casey about what this problem fucking was. Can I explain what I'm doing in simple terms? Preventing the collapse of civilization in one of the many subfields in which that needs to be done. That LLVM code was written by Graydon Hoare, original creator of Rust. Okay. I don't see what that means. This documentation says the count exceeds the 16 bits. Exceeds. Exceeds. If someone in chat ever writes a compiler, I may have saved them 5 hours. True. True. Okay. So we need to know that we're outputting cough. And how do we know that? We should also verify that we only set overflow result. I mean, it's really if target is, we only write Windows files or COFF files in Windows right now. So maybe I just assert on that. I don't think I want to add a new thing about like what's the format. All right. And okay. Okay. I already have OS target in right relocation. Oh, target. Didn't realize that was the same function. Yes, and I have OS target right here. So GG's. All right. Okay. That sometimes my brain just doesn't read the code. I am clearly too arrogant. What was I saying something lately? What did that guy even get mad about? Like, I don't even know. What was I saying that someone would get mad about? Collapse of civilization, maybe? Okay. I mean, I'm not claiming that I can single-handedly prevent the collapse of civilization. I'm saying I'm doing what I can to contribute to doing that. If someone wants to misinterpret that, that's their thing. Oh, that's the guy who said, can you explain what you're doing in simple terms? Yeah. I mean, the problem with that kind of a question is you can't answer it seriously because in a Twitch stream like this, even with 656 viewers, which is not that many for Twitch as a whole, but it's a lot more than like 5, right? If every time somebody comes in the channel and asks you to recap everything from the beginning, then you'll never stop recapping things from the beginning. And therefore, you'll never be able to do anything interesting for everybody else, right? So that is why we come up with entertaining responses. Well, quote, entertaining, unquote. You be the judge. But you know, like, we just can't be doing that. Like, imagine like Shroud, who has like 50,000 viewers at one time, right? And like every time somebody says, "Can you explain to me what game this is that you're playing and where you downloaded it from?" and all, like, it's untenable. It is untenable. Okay, well, you know what we get to do? Fixed the long-standing bug wherein large executables would sometimes get their code corrupt. I'm so happy to have that fixed. Let me just send Mark an email, who is the only beta user who is being bitten by this. This is fixed in the next beta, probably shipping today, tonight. Okay. Wow. Okay. So happy that that is fixed. Look at all the value, by the way, that is going to be delivered to the people in the next update. That is some value. It's weird that it never happened on your machine. Yeah. Oh, so you actually saw what the problem was? Yeah. I think it's just a lot of the time. Okay, I don't know what happens. Okay, I assume if that relocation lands somewhere outside the section, that's when we get the debug info error. But like, it was also stomping code when we don't get the debug info error, because like it landed inside a section, right? Or inside the text section. For your, I assume on your machine, it was happening every time. It was just stomping either code that was not really in use, or, you know, sometimes it stomps code in a way that it happens to generate valid instructions. Like that happened on a few of the test cases, and like it only crashed later. I don't know. Like I fully, seeing what it was, I fully see how it could have inconsistent results. Because yeah, it depends on the ordering of procedures in the text section, which I would think if we were running with no jobs would be consistent, but probably isn't, honestly. Anyway. Do I ever feel embarrassed, bad about bugs being reported? No, because this thing is really complicated. Like, it's an entire compiler for a C++ class language, by which I mean the level of abstraction at which it operates. And we go lower level than C++ now too, right? Because of the, Ryan's assembler and stuff. So, like at most companies, this would be a team of 25 people making this program or something like that. That's not an exaggeration. Like, you certainly at least, I don't even know, 25 would be lean, right? If you ask Google how big of a team do you need to make your compiler for a C++ class language, it's probably 200, right? 500? I don't even know. So like the fact that we're doing this with between 1 and 3 people, depending on what time it is kind of astounding, right? It does mean it's taken a little while in calendar time, but also calendar time helps with quality. Like if we went way faster, like 3 times as fast, a lot of the things about the design probably wouldn't be as good as they came out. So there's 600 people on Go. Yeah, I mean, you know, Go is at a different level of maturity though, so you can't, that's not an apples to apples comparison, but still. I'm just saying most people would not consider this to be possible with the number of programmers we have. And it works very well. Like once in a while, yeah, we have bugs, but they're not that bad. So, like this was the worst bug in a long time in terms of how hard it was to debug. And as far as I'm concerned, it wasn't even my fucking fault, right? It was Microsoft documentation's fault. So I don't know. I don't know what to say about any of this. Surely there's a limit of people after which there's no speed gain anymore. Yes. Yes, that is true. Okay. I am glad that that is stowed away. Oh my God, that was horrible. But okay, like here's the other thing, guys. This is the value to working late nights and weekends. The value is I started working on this at 7:30 p.m. last night. Then I walked home, whatever, went on the stream. I think we really started debugging it here at like 8:39 p.m. And it's the next morning and it's fixed. And this is probably one of the worst bugs in the history of the compiler in terms of like how flaky it is and how hard it is to track down. And like it was way less than a day. So, you know, that is what it is. I feel very good to have it squared away, though. I should just intuit what the docs mean. Yeah. The weird thing is, again, the docs are not technically incorrect. Technically. They're just honestly kind of misleading by omission. So, yeah. Can I suggest changes to the docs? I'm not going to bother. Like, suggesting anything to Microsoft has never gone well for me. They're not incorrect, they're incomplete. Yeah, that's a good way to put it. It's a good way to put it. So I kind of want to take a break and enjoy my Sunday and go have some ice cream now because that was rough. But yeah, if we gave you a beta code, I'll be sending those out later today probably, and then we'll deliver the value to the people. Let's you know what? We should run the tests. Whoops, we should run the tests and check in. Right? Right. Like watch all the tests horribly fail, right? Wouldn't that be great? Okay. Test passed. Boom. Value. I should have reviewed those diffs. Let's do that. I've got too many shells open. Let's do that postpartumly. Just to make sure I didn't hose things. Code view debug info. Okay, so we have an extra assertion in there. That's a good assertion to have. That's fine. Comments. Very good. Changed our relocation. Assertions. Added our definition here of that constant. Yep. And I accidentally clicked the help question. And a wonderful white space change. That I don't know why that happened, but okay. Great. Nothing bad in that check-in that I can tell. Do I plan to open source it someday? Yes. Just not for a little bit. Are beta keys handed out to chat? Well, I think I'm starting the tradition of doing that. So here's the thing. We used to grow the beta, pretty slowly by adding a couple people every week, just sort of depending on circumstances, right? But early on, when you don't have that many beta people, that's a sizable proportional growth in the beta community. But once you have 150 people in the beta, like we have, adding a couple people every week, like proportionally speaking, that's slower and slower growth, right? So we want to add more people, I think. Drops. All right. Thank you, everybody. We haven't rated anybody in a long time, so let's do that. Yeah, we need to figure out how to put drops in the compiler. Dude, I haven't rated anybody in months. You know how little that I've actually been streaming lately. Bonjour game. This must be something that people are interested in. He's got a lot of viewers in German. More German. It's Europe time. I keep forgetting this. Who should we raid? Game engine from scratch. That sounds good. I mean, he uses a lot of templates. That's why he's having a headache right now, because he uses so many templates. Did I fix the bug? Yes. We got the bug, guys. We are victorious. Bomberman Battle Royale. That could be entertaining. Okay, let's raid the dude who uses a lot of templates. Be nice. Don't tease him for using templates. Be supportive. He's having a hard time. And have a good day, everybody. We might stream again tonight or something. Bye-bye. We're giving him moral support to fight through the templates.